Chapter 4, Section 4.4, the other trigonometric functions. For our first example, we need to graph 3 tangent of x. So let's see how we can go about this. Well, we know that tangent has asymptotes at negative pi over 2 and positive pi over 2. So what you always want to do with tangent functions is always place the argument between these two values, negative pi over 2 and positive pi over 2. So the argument in this case is x, right? So that is basically it. Sometimes we need to solve for x. In this case, it's already solved for us. So this tells you where the two asymptotes should go. So let's draw our coordinate plane. So we got negative pi over 2 on the left side. We got positive pi over 2 on the right side. And then we need to find 3 midpoints. Well, the first midpoint between these two is clearly 0. So that one's an easy one to find. The midpoint between 0 and negative pi over 2 would be negative pi over 4. And the midpoint between 0 and positive pi over 2 would be positive pi over 4. So these are the two asymptotes. Negative pi over 2, positive pi over 2. And then tangent generally goes in this direction unless the coefficient is negative. If the coefficient is negative, then it would go in the other direction. But in this case, the coefficient is positive 3. So 1, 2, 3, 1, 2, negative 3. So at the first point at pi over 4, we know that tangent of pi over 4 is 1. So 1 times 3 is 3. And at negative pi over 4, it's negative 1. So negative 1 times 3 is negative 3. And at 0, tangent of 0 is 0. So there is our tangent graph. And they give us an interval. They want us to extend it a little bit further to the left and a little bit further to the right. So we can always do that by just extending in both directions. So the other asymptote would be way over here somewhere. The other one would be over here somewhere. So the period is pi. The distance between this value and this value is pi. That means you would have to go out to an additional pi in this direction. If you add pi to pi over 2, that's 3/2 pi. And then you'd find the midpoint. Over here, negative 3/2 pi. And your graph would look like that. All right. So that's example 1. Example 2, cotangent is very similar. The difference between tangent and cotangent is the asymptotes start at 0 and go to pi. The argument goes in the middle, negative 2x. And then we solve for x by dividing by negative 2. So we end up with 0. We have to switch the direction of the inequality because we divided by a negative number. So essentially what we have is negative pi over 2 less than x less than 0 is what we end up with. Right, so there's our 0, there's our negative pi over 2 asymptotes at those two angles. All right, midpoint is negative pi over 4. Midpoint is negative pi over 8. And then we got to find a midpoint over here. So we can add these two values and divide by 2. So if we add those two values, we're going to get negative 3 pi over 4. Right? So the middle is always 0. All right, and then for this value, well, cotangent generally looks like this, but we can just be sure by plugging in this angle into x. So if you plug in negative pi over 8, negative times a negative would be a positive. So you end up with, what is that going to be, positive pi over 4. Because two negatives become positives. 2 goes into 8 4 times, so you have pi over 4. Pi over 4, the cotangent of pi over 4 is 1, positive 1. But positive 1 times a half is a half. So there's 1, there's negative 1, so A half would be right in the middle. So at negative pi over 8, we're going to go up to a half. And then at negative 3/4 pi, that would be negative a half. So in this case, it's going to look very similar to the tangent graph. And the reason why is because of this negative. It reflected it. But usually, if this had been a positive, cotangent would have gone in this direction. But because of that negative, it flips it, it reflects it, and it looks like a tangent graph. All right, so that would be one complete cycle. All right, so in summary, if you have a tangent or a cotangent, your period is pi over b, and your horizontal shift is negative c over b. Important note that for cotangent, the asymptotes should be at 0 and pi, and your argument always goes in the middle. And for tangent, your asymptotes are at negative pi over 2, argument in the middle, and positive pi over 2. So that's very important, this and this. For cotangent, it's this. For tangent, it's this. All right, for cosecant, well, in order to graph cosecant, we need to graph sine first. So let's rewrite this in a different way. I like to write this as negative 3 cosecant argument. All right, and before we do that, we need to graph the sine of this first. So I'm just going to ignore this for now. That's just a vertical shift down 1 unit. But let's first graph sine. So to graph sine, we place the argument between 0 and 2 pi. All right, so the argument always goes between 0 and 2 pi for sine or cosine. All right, now we need to isolate the x. So in order to isolate the x, we should first subtract 3/4 pi. All right, so on the left side, we end up with negative 3/4 pi less than or equal to pi over 2x less than or equal to, let's see, this is equivalent to 8/4. So 8/4, 8 over 4, take away 3/4 is 5/4. All right, and then we have to multiply by the reciprocal of pi over 2, which is 2 over pi. All right, and that's going to cancel out the pi's. And that'll leave us with, let's see, 2 goes into 4 twice, 2 goes into 4 twice. So over here on the left side, we should get negative 3/2 less than or equal to x less than or equal to 5/2. All right, so this is the inequality, which tells us where the graph starts and where the graph ends. All right, so let's do that. Let's start with the coordinate plane. All right, so let's say negative 3/2 is over here somewhere. Positive 5/2 would be over here somewhere. Midpoint would be, if you add those two, you get 1. 1/2 would be the midpoint. Right, and then the midpoint between 1 and 5 is 3. And then the midpoint between these two values, if you add them, you get negative 1, so negative 1/2. All right, and sine always starts at 0. So we would start at 0 here because it's sine. And then because it's a negative 3, that means we're going to go down first instead of up first. So 1, 2, 3, 1, 2, negative 3. So first we're going to go down first to negative 3, then to 0, and then back up to positive 3, and then back to 0. So here is our dashed or dotted line. This is the sine curve, sine graph. And then there's always asymptotes at the X Intercepts, which would be there. And there. Because we have to remember to everything must shift down 1 unit. So actually this point would go to negative 4. This point would go to -1. So I'm going to shift everything in blue. So this point goes here, this point would go here, this point would go here, so on and so on. Everything would just shift down 1 unit. Oops. So now I can erase what I had. There we go. All right, and now finally for our cosecant graph, that's where you draw these graphs that look like U's or upside down U's, and that is the cosecant graph. All right, let's move on to the homework. All right, so let's see, fill in the blank. The period of tangent b over x, that's just the formula for that is pi over b. That's the period. All right, so as we said, tangent is always going to be between -pi/2. The argument goes in the middle, and +pi/2. And the coefficient is +9. So we can eliminate this and this because it must go through 0. Oh, actually, never mind. It does go through 0. So we must look at the y-axis. So it looks like it's going to be this one, not this one, because these are fractions. This one can also be a possibility, but the asymptote must be at +pi/2, which is this one. This one is at +pi, which is not the correct asymptote. So it has to be this one. All right, let's see. For this problem, so we have to remember that cotangent, the argument is between 0 and pi for cotangent, and the coefficient is -pi/7. So generally, cotangent looks like this, but because of that negative, it's going to go the opposite direction. So it's not going to look like these. It's got to look like this one or this one. And if you look at the coefficient, it's -1/7, so it has to be this one. There you go. So it's got to be this one right there. All right. The period of secant is the same as the period of cosine, and the period of cosine is 2pi/b, which is 2pi/8, which is pi/4. The period of this would be pi/b, which is pi/4pi, which is 1/4. One complete cycle. All right, so first we would have to write our inequality, which goes between 0 and 2pi for secant. Argument goes in the middle, and then we solve for x. So 2/pi, 2/pi. So we're going to end up with 0 less than or equal to x less than or equal to 4. Right, so we're going from 0 to 4. So it's got to be between this one and this one, and clearly this is the correct answer here. The period is going to be 2pi/b, which is 2pi/pi/2x, 2pi/b, which is 2pi/pi/2, which is, when you multiply by the reciprocal, is going to be 4. Okay, for cotangent, we write our inequality between 0 and the argument goes in the middle, and the right side is pi, and we multiply by the reciprocal here. So we are going to end up with 0 less than x less than 4. And then cotangent goes in this direction. So it could be this one or this one. It cannot be either one of these two. And between these two, it's going to be from 0 to 4. So it's got to be this one right here. All right. For cosecant, we first have to graph sine. And to do that, we place the argument between 0 and 2 pi. Divide by 2. And that's going to be 0 less than x less than pi. So that's going to be where our graph starts, 0, and where our graph ends is pi. So 0 to pi would be, this is a possibility. This is a possibility. This would not be a possibility because this is only half the graph. This has a period of 2 pi, and this has a period of 2 pi. So it's got to be between the top two. All right, so let's see which of these two it could be. All right, well, sine goes down first, so that would have gone down first like that, and then like that. So that would have been like this, sorry, like that. And as you can see, the sine curve would have gone down below, but it's on the top, so it's got to be this one because sine would have gone down first and then up second. And so this would have been the correct one. All right, the period of this graph would be 2 pi over b, which is 2 pi over 2, which is pi. All right, one complete cycle. For cotangent, you have to remember that the asymptote is between 0 and pi. The argument goes in the middle. And then we multiply by the reciprocal, which is 4 over pi. So we end up with 0 less than x less than 4. And because this is a cotangent, cotangents go in this direction, not this direction. So this is out of the question, and this one's out of the question. It's got to be between these two here. And between those two, let's see, 0 to 4, 0 to 4. They both go from 0 to 4. This one should be shifted up 2 units. And it looks like this one is the one that is shifted up. This one is shifted down. So it's got to be this one. All right, for tangent, same thing, but this time our asymptotes go between negative pi over 2, argument in the middle, and positive pi over 2. So let's solve for x. So on this side, we're going to have negative pi over 4, 3x. On this side, we're going to have 3/4 pi. Then we need to divide by 3. So we end up with negative pi over 12 less than x less than 3/12 pi. Right, and tangent is going to go in this direction, not this direction. So this one is out of the question. And so is this one. It's got to be between this and this one here. And let's see, the asymptote should tell us where to start and where to end. This is pi over 4, so this looks correct. And this one is not correct because this should be pi over 4. As you can see, this is the correct one. So it's got to be the top left. All right, and the period for this would be pi over b, pi over b, not 2 pi over b. So pi over b is the period, which would be, in this case, pi over 3. So that would be our period. And the horizontal shift is given by negative c over b, which in this case, negative c is, okay, negative pi over 4, double negative there. Negative of negative pi over 4 divided by b, which is 3. So double negative becomes positive. That's going to be pi over 12. And that does it for this section.